Howdy, AP PreCal. It is Miss Kosh. Today we are going to look at composition of functions and then the inverse of functions. I may break this into two videos, we shall see. I accidentally printed it two-sided and the paper bleeds through, so here we go. All right, on this first one, just a quick little reminder, operations of functions. I have these in here to practice talking about domain in addition to reminding us how to do these different operations. So here are the functions across the top. I have, so for addition, f of x plus g of x can also be written as f plus g of x, would be equal to, our function f is 3x minus 5, our function g is x squared minus 6x plus 8. Okay, when I add those together, I have like terms. I have x squared minus 3x plus 3. That is quadratic. Its domain is from negative infinity to positive infinity. And so that would go there and there. I'm just not going to write on the paper. Okay, I could put this in parentheses if I wanted to separate it apart, but it doesn't really matter. The next one, I'm going to do f of x minus g of x, and this one, the parentheses do matter. So this is our f of x, well, the first parentheses don't, but the second one does, because we need to distribute the negative. And so we get 3x minus 5 minus x squared plus 6x minus 8. I don't know that I needed to write that step, but there you go. So we have a negative x squared. We end up with a positive 9x. We end up with a negative 13. And once again, our domain is all reals because this is quadratic and there's no restrictions. Multiplication, be aware of the notation. It's f g of x or f of x times g of x, that sort of thing. And so we'll take, if I have f of x times g of x, I'll take f, which is 3x minus 5, and I'll multiply it by x squared minus 6x plus 8. I'm going quickly through this part because I think you should already know it. I'm going to FOIL. I'm going to do this. The only way to get x cubed is here. So this is 3x cubed. To get x squared, I'd have this or this. So this is negative 5x squared and a negative 18x squared. Negative 5 and negative 18 gives me a negative 23x squared. If I make a mistake, I apologize. Comment down below and we'll move on with our lives. Okay, then how do I get an x? I have 3x times 8. That gives me 24x. And I have a 5 times negative 5 times negative 6x gives me a positive 30. So positive 30, positive 24 is a positive 54x. And then I have a 5 times 8, and well, it's negative, but so negative 40. This is cubic. There are no restrictions on my domain, and there we go. The next one, okay, so then I was practiced with a few different divisions. I have two here because I want to talk about domain. The first one, f of x over g of x. My function f was 3x minus 5. My function g is still x squared minus 6x plus 8. You may notice that I intentionally wrote a quadratic that factors nicely. And so this is 3x minus 5 over x minus 4 times x minus 2. Okay, so what's the simplified? This is the equation. I mean, I'm happy enough with that where it's set to the resulting function. But this helps me find the domain. So x cannot equal 4, x cannot equal 2. So you could say it's the set x such that x is not equal to 4 or 2. Or you could say it's from negative infinity to 2, pick it up again from 2 to 4, pick it up again from 4 to infinity. Okay, and now let's look at, so I wanted to do that where we could factor the denominator. Because keep in mind, you can't divide by 0, you are not Chuck Norris. The next one was h over f. So my function h, this is the first one, so h of x over f of x would be equal to our h of x, way back here, x, the square root of x plus 5, divided by f of x was equal to 3x minus 5. With something like this, we have to consider both the square root and the denominator. So here, 3x minus 5 cannot equal 0, so 3x cannot equal 5, x cannot equal 5/3. Here, we cannot take the square root of a negative, so x plus 5 has to be greater than or equal to 0, which tells me that x has to be greater than or equal to negative 5. So this is easy to work with a number line. I have negative 5 and I can include that value, and then I have 5/3, and I cannot include that value, but I have to be bigger than -5. So in interval notation, I would write this as -5 to +5/3, pick it up again from +5/3 to infinity. Okay, that was this one right here. Life is good. Okay, now we're going to look at the composition of functions, and it kind of looks like fog sometimes. Can you see what that looks like? We read this is f of g of x is how we say that, okay? And you can write it this way, f of g of x, writing it out like this. So we wouldn't necessarily say fog x. I mean, yeah, we know what you mean, sort of, but that's not proper math lingo. It's f of g of x, and so what we'll do is we'll come along here and take f of g of x means we write out our function f, which was 3 times something minus 5. Well, what is that something that we're putting in for x? Well, we're now putting in g for x. Let's look back up here. G is x squared minus 6x plus 8. Pretend I gave myself enough space. I see 3x squared minus 18x. This will be plus 24 minus 5. 24 minus 5 is plus 19. And my domain is -infinity to positive. Did I do the domain on the last? Yes, I did. Okay. And this is just quadratic, so its domain is all real. Super. The composition, okay, now here's why I'm doing 3. I wanted to show you that f of g of x and g of f of x may not be the same. So this is g of f of x, and you can write it like this. That helps you see a little more clearly. So let's see. G of f of x means I come along and I write out my g function. And anywhere I had an x before, I'm now plugging in f. Okay, and so this becomes 9x squared. 15 times 2 is minus 30x plus 25 minus 18x plus 30 plus 8. I'm moving fast today, you guys. So if I make a mistake, please comment down below. 9x squared. This becomes minus 48x. I see 25 and 30, that's 50. 5 plus 8 gets me 63. And my domain for our quadratic is all reals. Okay, last one, I wanted to look at something kind of weird. I think this one I wrote because of the domain situation. So this is h of f of x. So what was h? H was the square root of something plus 5. What is that something? That something was f. So this is 3x minus 5. Oh, okay, well that's actually pretty straightforward. The 5's cancel, and I get the square root of 3x is my, what did I call it? Resulting function. And its domain, 3x has to be greater than or equal to 0, which means x has to be greater than or equal to 0. And so in interval notation, it's 0 to infinity. Okay, and that's the front of this page. Hopefully that was mostly a review for you. If not, well, hang around. Well, and now we're going to get into kind of that AP style of dealing with these questions. So here we go. The function f is called the function f of x equals x is called the identity function, because f of g of x equals g of f of x, which would equal just g of x. It gets you back to where you started. So for example, if I have, say my function g, if g of x equals, my birthday is 6/17. If it's 6x squared minus 17, okay, then what happens? What's f of g of x? Well, it means x, and so I have x, and what am I plugging in? I'm plugging in g, which was 6x squared minus 17, which is exactly where I started. Or if I do it the other way, if I say g of f of x, g is 6 times something squared minus 17. What's the something? Well, f, and we said f is the identity, so this is x. Well, that's exactly 6x squared minus 17. That's exactly where I started. So notice on this, f of g of x equals, it's the identity function if you don't need to use it in composition. It kind of is a weird way. Here's the whole point of that. They're going to give you a function and ask you to find it they're saying here that h of x is equal to f of g of x, and we need to figure out what those functions are. Okay, so h of x is equal to f of g of x, and they're telling us that this is 2 root square root of x squared, or square root of x squared minus 9 plus 5. So what we can do is one option, and I think when I worked our practice, I had like 3 options for everyone, and you might match mine, you might not, but I can say f of x is equal to 2x plus 5. If I say that, then my g that I'm going to plug in here for x is going to be this right here, the square root of x squared minus 9. So if I do if I do f of g of x, and all of this gets put in here where that x was, then I'd end up back where I started. Another option is that f of x could equal 2 square root of x plus 5. Well, if that's the case, then what am I plugging in for x? Well, I'm plugging in this mess. Can you see this? Maybe I should zoom in. I'm plugging in x squared minus 9 into that x, and so that's another option. What else could I do? I could say, I don't know what I wrote in my answer key, but option 3, I could say f of x is equal to, I could say x plus 5, and then what am I plugging in for g? I'm plugging in 2 times the square root of x squared minus 9. If I take all this and plug it into that x, then I end up where I started. Okay, so far so good? Another part that AP PreCal makes a distinction of, or makes a point about, is how you can relate transformations to compositions, which I was like, oh, well, that's interesting. So here's my attempt to teach this. They're telling us f is translated vertically k units. Okay, so we're taking our graph and we are translating it vertically. So that means it's f of x plus k. Okay, so now in this case, h is going to be either f of g of x or g of f of x. Well, so what do we want? Ultimately, because it's translated vertically k units, so we are going up. It might be down, well, in this case, let's just assume this is positive, everything's good. What we want here is if I say that h of x is equal to g of f of x, I would end up getting this something plus k. Well, what is that something? That something is f of x. So now I have f of x plus k, and that's what I wanted with my vertical shift. Yeah, I should call it my vertical translation. I'm trying to use AP language, and it doesn't, I've had too many years of not using it. It's a fight. Okay, so this one, the answer is that it's g of f of x. This one, I think I should have said, is translated horizontally negative k. I think I should have made that a negative k right here. So now if I shift left and right, what that's going to ultimately do, if I have f of x plus k, this is going to move me left k. And so that should have been a negative in my notes here. So what is this doing? This is saying this h of x would be equal to f of g of x. Okay, so it's f, we don't know, g of x is equal to this x plus k. So when I plug g into f, this is what I get, and that's what I wanted with a shift. So I think the only thing that, as I was writing this, I was struggling, but I think this should have been a negative k. Okay, we can also look at dilations. So if it's vertically dilated, that means that we're going to end up with k times f of x, because that would be a vertical dilation by a factor of k. And so what's happening here, that our h of x is going to be g of f of x, because g is k times something. What is the something? The something was f of x. This matches what a vertical dilation should look like. Okay, f is horizontally dilated 1 over k. Okay, this I took care of that. I did not do correctly. My apologies. So this means that it's f of k times x in here, which is going to give it a horizontal dilation by a factor of 1 over k. And so what does this mean? This means, not an equal sign. This means h of x would be equal to f of g of x. Okay, so it's f of, what was g? G is kx. So this would be f of g of x is equal to f of kx, which is what we wanted with our horizontal dilation. Okay. Oh, good. That's inverse. We're almost done with composition. Okay, so then they like to give us an equation and give us a table and all this kind of stuff. And so we're looking at, I said in here, let k of x equal f of g of x. And so k of 1 would be would be f of g of 1. Okay, so now let's look. G is here. So when x is equal to 1, what is our y value? And our y value is 0. So this will be equal to f of 0. Now, f of 0 means I have to go back to this equation. I have 2 to the 0 is 1, minus 0 squared is 0, so this is just equal to 1. Okay, k of 2 means f of g of 2, because, right, this was f of g, okay? So g of 2, here's g of 2 is equal to 1. Okay, so we have this will be equal to f of 1. We've taken care of this part. F of 1, we come back here. This is 2 to the 1 minus 1 squared. 2 to the 1 is 2, minus 1 squared is minus 1, so 2 minus 1 is 1. Oh, they were both 1, but we got there in a different way. Okay, the next one, we have this k of 1, but our new k is h of g of, oh, Ms. Kosh, what were you thinking? I know, I'm not a nice person. Okay, so f of 1, oh, we just did f of 1. We said f of 1 was equal to 1, so this part becomes, this is going to be equal to h of g of 1, okay? G of 1 is equal to 0, so now this is going to be h of 0. H of 0 is equal to 2. That's a 2. Can you read that? I would argue this is tedious, but not necessarily difficult. Well, anyway, if it's difficult, I apologize. Okay, so this is h of g of f of 2. Did we do f of 2 yet? No, let's do that. Okay, so we have 2 squared minus 2 squared. Oh, look at that. So that's 4 minus 4 is 0. So this becomes h of g of, this part was 0. Okay, so g of 0 is negative 1, so now we need h of negative 1. H of negative 1 is equal to positive 1. I tried to keep these numbers nice and neat and clean and whatever, and there we go. Okay, so that is the end of my notes on composition. So I will be back and see you again in the next video on inverses. All right, like, subscribe, comment, let me know how I can help you, and go practice.